All right, so today we are going to do our third day of radicals. All right, and today we're going to do operations. Today we're just going to do addition, subtraction, and multiplication. All right, and the general rule is that when you are adding and subtracting, it's kind of like when you add or subtract the variables. You have to have like terms. Well, with radicals, like terms meaning having the same thing underneath a radical or a cube root or a fourth root or a fifth root. You cannot combine them unless you have the same number underneath the radical. All right. Multiplication, just like with adding, like if you do 2x and 3x, it's 5x. But you can't add 2x and 2y because x's and y's are different. With multiplication, though, it doesn't really make a difference. They do not have to be the same thing underneath the radical. All right, you're just going to do outsides to outsides, insides to insides. All right, so let's start here with some addition and subtraction. So we have square roots here. We notice we have the exact same thing underneath the radical, which means we are just going to combine and you just add the outsides together. All right, so 3 plus 4 is 7, and then what's underneath the radical just stays there. So it is 7 root 5. Just like 3x plus 4x be 7x, 3 root 5 plus 4 root 5 is 7 root 5. All right, here we have a fourth root. Doesn't make a difference since they're both the same. They're both a w, So you just go what's on the outside, you're going to combine them. If there's nothing there, we assume it's a 1. 1 minus 6 is negative 5. So it's negative 5. Whoops, that's an awful 4. Fourth root of w. All right, negative 5, fourth root of w is your answer for that one. All right, now 3. We don't have the same number. We don't have 8 and the square root of 18. So what you want to do is simplify them first. The square root of 8 is actually, could be rewritten as 2 root 2, right? Because 8 is 2 times 2 times 2. One of the 2's comes out. 18 is 9 times 2, which is 3 root 2. Now they are the same. All right, root 2 is there, root 2 is there. So you just do 2 plus 3, which is 5, and I get 5 plus the square root of 2. And there's my answer for number 3. All right, number 4. All right, same thing. These are not the same, so let's simplify them. So this is what we did the other day. All right, 16, the cube root of 16. Remember, 16 is 2 to the 4th. It's 2 times 2 times 2 times 2. So I'm going to have a cube root. The 2 comes on the outside. There's 1, 2 left over. All right, how many times does 3 go into 4? 1 time. So there's 1x. On the outside, 1x left over. How many times does 3 go into 3? 1. So there's no y's left over. So that's 2xy cube root of 2x minus. All right, so now we'll do the same thing for this one. All right, 54. Now, I know this is 27 times 2. All right, and 27, the cube root of 27 is 3, and there's a 2 left over. All right, remember, the worst case scenario, if it's 9, this is 9 and 6, 3, 3, 3, and 2. So there's where my 3 3's are. That's why the outside with a 2 left here. All right, hopefully you know that's 27 times 2. The cube root of 27 is 3. That's why the 2's there. Okay, now 3 goes into 4 one time with a remainder of 1. 3 goes into that evenly. All right, so we have 3xy cube root 2x. So now we just have to subtract them. 2x minus 3xy is negative xy cube root of 2x. And there is your answer. All right. Number 5. All right, now we're into multiplication. All right, now we're in multiplication. Does not have to be the same thing. All right, so you just have to do outsides by outsides, inside by insides. So you get 20 and you get 18. Now the problem is 18 can be simplified. And hopefully what you realize is if I do 6 times 3, All right. 6 is 3 times 2. I'm going to end up with something that I can pull out. All right. So 18 we know is 3 root 2. And so I have to pull out a 3, but there's already 20 outside. So 20 times 3 is 60. So I get 60 root 2. So you just have to make sure that the whole thing is simplified. Okay. Now for this, 3a squared times 6a. You could simplify first, or you can simplify later. It doesn't really make a difference. I would probably multiply this first, then only have to simplify once. All right, so 3 times, so I get 18a cubed. All right, so I get the square root of 18 cubed, all right, which is 18 is 3 and 2. A squared is, I did a cubed, so 2 goes into it one time with 1 left over. So it is 3a square root of 2a. All right. Now for 7, cube root of 4 times cube root of 4 times cube root of 4. All right, this is not just 4. All right, before when we did like the square root of 4 times the square root of 4, it would just be 4. It's whatever is in here, but it's a cube root. So this is 4 times 4 is 16, right? So we have this cube root of 16, which is really 2 to the 4th, which is 1, 2 comes out, 2 cube root 2. All right, 2 cube root 2 is your answer. As long as these are the same, you can multiply them together. All right, what do you think you would do here? Distribute. All right, so here, there to there. So 3 root 2 times 4 root 2. 3 times 4 is 12. Root 2 times root 2 is 2, so I get 24. 3 root 6. Because 3 times 1 is 3, 2 times 3 is 6. So it's 24 minus 3 root 6. All right, number 9. 2 terms, got 2 terms here, 2 terms here. We are going to just FOIL these out. All right, so 2 root 3 times 3 root 3. All right, 2 times 3 is 6. 3 times 3 is 3. 6 times 3, that's going to give us 18. All right, 2 root 3 minus times 2 root 5. I'm sorry. So 2 times that is negative 4. 3 times 5, so I get negative 4 root 15. But when I do root 5 to here, I get positive 3 root 15. So they get combined because they're like terms, just like we can when we normally FOIL stuff out. The 2 terms, middle 2 can be combined. That's negative square root of 15. Since they're the same, you can combine them. And then square root of 5 times negative 2 root 5 is negative 2 times 5 times root 5 times root 5, which is 5, minus 10. I get 18 minus 10, which is 8. So it's 8 minus the square root of 15, or negative 15 plus negative root 15 plus 8. Same thing. All right. Move down here. All right, squaring. 2 terms, we're squaring them. Same thing. Just do the trick we normally do, which is square this, which is 9. Multiply this and double it. So if I multiply 3 times root x minus 9, it's 3 root x minus 9. Double it, becomes 6 root x minus 9. Remember, we want to work efficiently. And what's the square root of x minus 9 times the square root of x minus 9? It is x minus 9 without the square root. These 9s cancel, and you're left with 6 root x minus 9 plus x. There's your answer. Okay. Looking at 11, you should notice something. 3 and a root 2, 3 and a root 2, opposite sign. These are what we call conjugates. So you just have to square the first and square the last. Multiply first and last. Root 3 times root 3 is 3. Root 2 times root 2 is 2. 3 minus 2, 1. And there's your answer. It's just 1. All right. 12. All right. Last 2 here. Now, what you should notice is that these are different roots. All right. So we can't multiply just 2 times 2 is 4. All right, so what we need to do is convert this to a rational exponent. All right, we learned about this last class. This is 2 to the 1/3. This is 2 to the 1/4. What happens when I have these two bases the same? What do I do with the exponents? I add them. Well, what's 1/3 plus 1/4? Well, let's make them a common denominator, which would be 12. So 1/3 is 4/12 plus 1/4, which is 3/12, which equals 7/12. So this is really 2 to the 7/12. And the answer needs to be rewritten in radical form. So we're going to go back to radical form. Remember, the bottom number is your root. So it's the 12th root to 2 to the 7th. And you can actually make that 2 to the 7th. Let's see. 2 to the 6th is 64. So 2 to the 7th is 128. All right. So it is the 12th root of 128, or the 12th root of 2 to the 7th power. All right. Now for this one, the cube root of 2 times the square root of 3. Well, if I change this, I get 2 to the 1/3 times 3 to the 1/2. I can't add these. Why not? Because they don't have the same basis. All right. They don't have the same basis. So what you want to do here is you want to make these the same. You want to make the indexes the same. All right. So we call here the roots. So watch what happens. If I made this the 6th, right? 1/3 is 2/6, correct? 1/2 is 3/6. So I can rewrite this as the 6th root of 2 squared, which is 4, times the 6th root of 3 cubed, which is 27. Since they have the same root, I can now multiply, and my final answer is 4 times 27, or 2 squared times 3 cubed, which is 108. 6th root of that. That cannot be simplified. Why not? Well, because that's 2 squared, that's 3 cubed. It's 2 squared times 3 cubed. There's not 6 of anything. All right, so there's your final answer. All right, so if the numbers here are the same, you're just going to be able to add them and be good. If they're not, you're going to have to make the roots the same. And you do that by same sort of premise, getting the common denominator, changing it back to radicals, then multiply. All right, so that is our notes on adding, subtracting, and multiplying. Remember, when you're adding, you need to have the same number underneath the radical. If it's not the same, then you have to make it the same. And with multiplication, you just do outsides by outsides, insides by insides. All right. I hope you guys have a great day.